our day-to-day life, we are using so many solutions. What is solution? Listen here. I take some water in this tumbler. This water is a solvent, you know already. Now, I am adding a salt of 1 spoon to this water. This salt is a solute here. If the solute is dissolved in this solvent, I get a solution. Okay? Now, I added only 1 spoon of salt. What about the concentration of this solution? This solution has a particular concentration. Now, again I am adding another spoon of salt to the same solution. Now, the concentration of the solution increases. Okay. What is concentration? Concentration gives the amount of solute dissolved in the particular quantity of the solvent. So, concentration means the amount of solute dissolved in the particular quantity of the solvent. The amount of solute and the quantity of solvent can be expressed in many units. Say for example, the amount of solute as well as the quantity of solvent can be expressed in grams, kilograms, milliliter, liter or moles. All these units can be used to express the amount of solute and solvent. So, depending upon the unit used to measure this amount of solute and solvent, solution can be expressed or concentration of solution can be expressed in many methods. What are the methods used to express the concentration of the solution? Molality, molarity, mole fraction, normality, formality, mass percentage, volume percentage, mass by volume percentage, ppm, parts per million. These are all the units used to express the concentration of the solution. Now, let us discuss one by one. First one, molality. Molality, it is denoted by the letter small m. Small m denotes molality. What is molality? It gives the number of moles of solute dissolved in 1 kilogram of the solvent. So, by formula we can give it as molality is equal to number of moles of solute, number of moles of solute divided by mass of solvent. It should be in kilogram. So, molality can be expressed as number of moles of solute present in 1 kilogram of the solvent. Let us take one example to calculate this molality. Imagine 90 gram of glucose, 90 gram of glucose C6H12O6 is the molecular formula for glucose. 90 gram of glucose is present in 2 kilogram of water. What is the molality of this solution? Actually, number of moles of solute should be calculated first. How to calculate number of moles of solute? You know it already. If the mass of the solute is divided by molar mass of the solute, it will give you what? Yes, it is number of moles. So, number of moles equal to mass by molar mass. You know what is molar mass already you studied. So, here 90 gram of glucose is dissolved in 2 kilogram of water. What is the number of moles of glucose here? Mass is 90 divided by what is the molar mass of glucose? Yes, 180. So, number of moles is equal to 1 by 2, that is 0.5. 0.5 moles. So, 0.5 mole is present in how many kilogram of solvent? 2 kilogram of solvent. So, the molality of the above solution is M is equal to number of moles is 0.5, mass of solvent is 2 kilogram. So, divided by 2, which is equal to 0.25 m. So, the molality of the solution is 0.25 m. Here in molality, the mass of the solute is expressed in moles. The amount of solute is expressed in moles, amount of solvent is expressed in kilograms. Now, let us move to the next, molarity. This molarity, just one word is, one letter is different, it is molality, this one is molarity. It is denoted by the letter capital M. So, small m for molality and capital M for molarity. What is molarity? It gives the number of moles of solute present in 1 liter of the solution. Actually, molality gives you the number of moles of solute in 1 kilogram of the solvent, whereas molarity tells you the number of moles of solute present in 1 liter of the solution. So, molarity formula is given by M is equal to number of moles of solute divided by volume of solution, and it is given in liter. Number of moles of solute divided by volume of solution in liter. Let us calculate the molarity of a solution with an example. Say 45 gram of the same glucose C6H12O6 is present in 2 liter of the solution. 45 gram of glucose dissolved in 2 liter of the solution. What is the molarity? Molarity is equal to number of moles of solute. What is the number of moles of solute here? It is given by, again, mass by molar mass. So, what is the mass? It is 45 and its molar mass 180. Now, calculate this. It is equal to 1 by 4, that is equal to 0.25 moles are here. The 0.25 moles are present in 2 liter of the solution. So, molarity is equal to 0.25, that is number of moles divided by volume of solution in liter, that is equal to 2, which is equal to 0.125 m. So, in this way we can calculate molarity of any given solution by knowing the molar mass of the solute, isn't it? The mass should be divided by molar mass and the number of moles should be divided by volume of the solution in liter. Next one, mole fraction. The third one, mole fraction. What is mole fraction? To understand this, let me to give an example. Suppose in our class 50 students are here. Among the 50 students, 20 students were interested in cricket and 20 students are interested in, say, kabaddi, and the remaining 10 students in hockey. So, can you calculate the fraction of the students who are interested in cricket? Yes. How can you calculate this? 20 students are interested in cricket. Total number of students in this class is 50. So, 20 by 50 is the fraction of the students who are interested in cricket. or you can expand this like as 20 students are interested in cricket divided by the total number is what? 20 cricket players plus 20 kabaddi players plus 10 hockey players. It indicates you what? So, this 20 is the cricket players, that is students involved in a particular game, which is divided by total number of students present in that class. This total number includes cricket players, kabaddi players as well as hockey players. In the same way, a solution may contain 2 or more components. The mole fraction can be calculated for each component. Here, if mole fraction is, this mole fraction is first denoted by the letter x. It is denoted by the letter x. If a solution contains A and B as the components, now mole fraction of A is denoted by XA and mole fraction of B is denoted by XB. This XA is equal to what? If you take this A as solute and B as solvent, take this A as solute and B as solvent. So, now mole fraction of solute A, that is XA, is equal to number of moles of A, that is number of moles of solute divided by number of moles of all the components. That means here what? Number of moles of A plus number of moles of B. In the same way, XB can be written as number of moles of B divided by number of moles of A plus number of moles of B. So, mole fraction of any component is given by the number of moles of that particular component divided by total number of moles of all the components. It is interesting to note that always the sum of the mole fraction of all the components will be equal to 1. That is, here we have two components A and B. If you add mole fraction of A, that is XA, with mole fraction of B, that is XB, you will get the answer of 1. It is always equal to 1. So, if you calculate mole fraction of one component, then if you know the mole fraction of XA, then you can get XB by subtracting from 1. So, XB is equal to 1 minus XA. So, always the mole fraction of all the components, summation of all the components is equal to 1. So, if you know the mole fraction of A, you can calculate mole fraction of B by subtracting like this 1 minus XA. Similarly, if you know the value of XB, that is mole fraction of solvent, then you can calculate this XA as 1 minus XB. So, XA is equal to 1 minus XB. So, this is about the mole fraction. Then the next unit is normality, which is denoted by the letter capital N. Normality is denoted by N. What is normality? It is very similar to this molarity, only the difference is here we are taking number of moles of solute. Instead, in calculation of normality, we have to calculate the number of gram equivalents of the solute. Number of gram equivalents of solute present in 1 liter of the solution is known as normality of the solution. How to calculate number of gram equivalents? It is given by the formula number of gram equivalents divided by volume of solution. This volume should be in liter. So, number of gram equivalents is nothing but mass by equivalent mass. Mass by molar mass will give you number of moles. Mass by equivalent mass will give you number of gram equivalents. How to calculate equivalent mass? If the atomic mass is divided by the valency, atomic mass divided by valency will give you equivalent mass. Say for example, calcium has atomic mass of 40. You know its valency is 2. So, 40, that is atomic mass, divided by its valency 2 will give you equivalent mass of calcium, that is equal to 20. So, in this way you can calculate equivalent mass, that is atomic mass divided by valency will give you equivalent mass. The mass of the solute divided by equivalent mass will give you number of gram equivalents. So, number of gram equivalents divided by volume of the solution in liter will give you normality of the solution. Next one is formality, which is given by the letter capital F. Formality given by the letter capital F. What is formality? To understand this, you have to know what is formula mass or formula weight of the solute. Say take example of NaCl, our table salt. You know how to calculate formula mass for this NaCl? The mass of or atomic mass of Na is 23. Mass of chlorine is 35.45 or approximately 35.5. If you add the mass of these two, that is sodium and chlorine, you will get the value of 58.5. This is the formula weight of NaCl. In this way, you can calculate the formula weight of glucose as 180, or for any compound you can calculate formula mass like this. Now, what is formality? Number of formula weight of the solute divided by volume of the solution in liter. Number of formula weight. What is number of formula weight? You know number of moles equal to mass by molar mass. Number of gram equivalents equal to mass by equivalent mass. And number of formula weights is equal to mass by formula mass or formula weight. So, divided by volume of solution in liter. Let me to explain this with an example. If 5.85 gram of NaCl is dissolved in 1 liter of water, what is formality of this solution? F is equal to number of formula weight, that is mass is 5.85 divided by its formula weight is equal to 58.5, which is equal to 0.1. The 0.1 formula weight is dissolved in 1 liter. So, which is equal to 0.1 F. This is the formality of the solution. Next one is mass percentage. Mass percentage. This is given by, mass percentage is given by percentage W by W. This W is the weight of the solute in gram, and the next W indicates you the weight of solution in gram. Say for example, if 50 gram of the solvent contains 5 gram of the particular ingredient. Say consider this as ointment. 50 gram of particular ointment contains 5 gram of one active ingredient. what is the mass percentage of this? So, 50 gram contains 5 gram. You know percentage means for 100. So, 5 divided by 50 into 100, which is equal to 10 percentage W by W. This is the mass percentage of the particular ointment. In this way, you can calculate mass percentage for any substance, any solution. Here you have to keep one thing in your mind. The mass or weight of the solute as well as solvent should be given in gram. The unit should be given in gram only. Next one is volume percentage. Volume percentage. This is given by percentage V by V. Volume percentage. Now you can say yourself, here we are using W by W in mass percentage, V by V in volume percentage. That means what? The mass of the solute as well as mass of the solution are given in weight, that is gram in this mass percentage. Whereas in volume percentage, volume are given in milliliters. So, volume of solute should be in milliliter as well as volume of solution in milliliter. This is the formula to calculate volume percentage. Here it should be multiplied by 100 to calculate percentage. So, volume of solute in ml divided by volume of solution in ml into 100 will give you volume percentage. The next one is mass by volume percentage. What is that? Mass by volume percentage, that is equal to mass of the solute is given in gram. So, mass of solute in gram divided by volume of solution in ml. It should be multiplied by 100 to get the percentage. So, mass of solute in gram divided by volume of solution in milliliter, that should be multiplied by 100 to get the mass by volume percentage. Next one is parts per million, that is ppm, parts per million. What is million? Can you write the number? 1, 10, 100, 1000, 10,000, 100,000, million. You can write it as 10 power what? 1, 2, 3, 4, 5, 6. So, it is equal to 10 power 6. This 10 power 6 is million. So, how many parts are present per million parts? That is parts per million. So, parts per million, that is ppm, is equal to mass of solute divided by mass of solution. It should be multiplied by this million, then only you can get parts, how many parts per 1 million. So, into 10 power 6, which will give you ppm value. Usually in tap water or sea water, the TDS value, total dissolved solid value, will be calculated in this unit only, parts per million. So, mass, solute and solution should be in the same unit, all should be given in the same unit. So, by knowing this type of expressing concentration of the solutions, you can calculate the concentration of solution very easily.